Imagine a zipper exploding with the force of a billion nuclear bombs. It sounds impossible. Yet it happens every time you zip up your jacket. This phenomenon is known as the zipper shockwave, where the sudden compression of the zipper teeth releases an enormous amount of energy. Scientists have long been fascinated by the zipper's ability to withstand such incredible forces, but also wondered why it sometimes fails catastrophically. To understand the zipper's behavior, we need to delve into the world of materials science and explore the properties of polymers. Polymer fibers, like nylon and polyester, are made up of long chains of molecules that are incredibly strong and flexible. However, when subjected to rapid compression, these fibers can become brittle and prone to breakage. The zipper's teeth are made from these very same fibers, which explains why they can sometimes shatter under the force of the zipper's teeth. But that's not the strangest part. The zipper's failure is not just a matter of the materials, but also of the way they're structured. The zipper's teeth are arranged in a specific pattern, with each tooth overlapping the one below it by a tiny amount. This arrangement creates a zipper lock, where the teeth are able to interlock and hold the zipper in place.
However, when the zipper is pulled too quickly, the teeth can become disengaged, causing the zipper to jam or break.
And then something unexpected happened. Researchers discovered that the zipper's failure can be predicted using mathematical models. By analyzing the behavior of the zipper's teeth and the surrounding material, scientists can pinpoint the exact moment when the zipper will fail. This breakthrough has significant implications for industries that rely on zippers, such as aerospace and automotive. For example, if a zipper fails in a critical system, it can lead to catastrophic consequences, such as loss of life or expensive repairs. The zipper's failure is not just a matter of aesthetics, but a serious safety concern. To mitigate this risk, manufacturers are now using advanced materials and designs that can withstand the stresses of rapid compression. One such material is a type of fiber called polyethylene terephthalate, or PET for short. PET fibers are incredibly strong and flexible, making them ideal for high-performance applications like aerospace. However, the use of PET fibers also presents a new challenge: how to ensure that the zipper's teeth remain securely locked. To address this issue, researchers have developed a new type of zipper tooth that uses a unique combination of materials. The new tooth design features a specialized coating that helps to reduce friction and prevent the teeth from becoming disengaged. This innovation has the potential to revolutionize the zipper industry, making it safer and more reliable for a wide range of applications. But the story of the zipper doesn't end there. Scientists are now exploring new ways to use zippers in innovative fields like biomedical engineering. For instance, researchers are using zippers to develop new types of implantable devices, such as pacemakers and insulin pumps. The zipper's unique properties make it an ideal candidate for these applications, where precision and reliability are paramount. The use of zippers in biomedical engineering has the potential to transform the way we approach medical devices. To achieve this goal, scientists are working to develop new types of zippers that can withstand the stresses of the human body. One such innovation is a zipper made from a special type of fiber called nanofibers. Nanofibers are incredibly strong and flexible, making them ideal for applications where precision is key. The use of nanofibers in zippers has the potential to revolutionize the field of biomedical engineering. However, the development of these new zippers is not without its challenges. Scientists must carefully balance the properties of the fibers with the demands of the application. To achieve this balance, researchers are using advanced computational models to simulate the behavior of the zipper's teeth. These models allow scientists to predict the zipper's performance under various conditions, making it possible to design and test new zippers more efficiently. The use of computational models in zipper design has the potential to accelerate the development of new zippers and improve their performance. The zipper's story is one of innovation and discovery, where scientists and engineers are constantly pushing the boundaries of what is possible. As we continue to explore the properties and applications of zippers, we may uncover even more surprising and fascinating facts. The zipper's history is a testament to human ingenuity and our ability to solve complex problems. From its humble beginnings as a simple fastening device to its current applications in aerospace and biomedical engineering, the zipper has come a long way. The zipper's story is a reminder that even the most mundane objects can hold secrets and surprises waiting to be discovered. Want to learn more about the fascinating world of food science and cooking chemistry? Subscribe for more incredible stories like this and join our journey of discovery. Fascinating mind, and we'll see you in the next video blowing facts and join our community of curious learners. Watching Mind, and we'll see you in the next video.